Meeting is now being recorded.
Welcome to Data Management Fundamentals for Effective Government. My name is Chris Arroyo, Account Manager at IMIX Group, host of today's presentation. IMIX Group is a federal small business that provides technology products and services to the public sector. We're one of the fastest growing private companies in the DC metro area and, since our founding in 1997, have sold over $2 billion in technology products and services to every federal government agency and many major state and local organizations nationwide. Our presentation today will run about an hour, including time for questions and answers at the end of the presentation. Please feel free to enter your questions into the pod to the left of your main screen. I'll be collecting them for the Q&A period at the end. This presentation is being recorded, and an archived link will be emailed to you within the next couple of days. Please note the toggle button near the top right of the presentation pod that reads Full Screen. At this time, you are invited to click on this toggle in order to better view the screen. At the end of the presentation, you will be asked to toggle back to this view in order to enter any questions you may have into the Q&A pod. Today's speakers are David Lotion, President of Knowledge Integrity Incorporated, and author of numerous books on data quality, and Naveen Sharma, Global Portfolio Director, Data Management Solutions with Pitney Bowes Business Insight. And now I'd like to turn our presentation over to David Lotion.
Thanks a lot. I appreciate the introduction. I also always like to thank the sponsors of these opportunities to chat about information management, data quality, and master data management, et cetera. So I want to thank the folks at Pitney Bowes Business Insight for providing the forum to do such. And I think we're sitting on the agenda slide where what I'd like to be able to talk about is our experiences. We're a small company. We've done a bunch of consulting engagements with organizations that are either consulting to contracting to the federal government, or we contract directly with the government, and we've seen some recurring themes with respect to information management and some of the challenges that emerge from the past in reflection of what is anticipated in the future. So for today's talk, I'm going to try to hit on these bullet items. Number one, looking at the organic development of systems in government agencies and how that's created some particular challenges to information sharing. Then we'll talk about some of the emerging scenarios for data use, and really what I'd like to focus on is not just use, but multiple use or data sharing. Then we'll look at the differentiation between what we might call data management or management of the data versus information management, and to that I specifically refer to being able to take advantage of changing data into useful and actionable information. Then, what are some of the embedded challenges that are left over from our historical organic architecture? And then, how can we leverage technology plus process to have more effective data use for effective data government? So let's move to the next slide. Here's a perception, or kind of a reference, a graphic of the way that we've developed our systems over time. Typically, when there's a need to implement some kind of business process or some kind of operation, we sit down and we say, okay, we need to build an application. The application has certain functional requirements, and then we build an underlying data subsystem that supports achieving those core functional requirements. And these systems are really built to address the operational needs without really considering whether there's a need for an overall information architecture or whether there's any need in the future for information sharing. So we've got some kind of system that manages beneficiaries. So we have a beneficiaries data set, or we have a legal department, or et cetera. And so there's legal data, or there's management of human resources, so there's HR data, or there's in public safety, there's crime data, et cetera. And we end up having all these data silos. But what we're finding, if we go to the next slide, what we're finding is that there's an increasing recognition of the value of sharing information among groups within the same organization or within the same agency, as well as even more to the point, across agencies. And when we start to see processes that can benefit from having better access to more visibility into information that represents the same concepts, then there's an expectation that our business processes are going to be more effective. However, the same issues that crop up from historical evolution of our systems create some of these barriers. For example, we have budget data in a finance group within each agency. Well, a lot of these things a lot of these data systems talk about the same concepts, but this is siloed within each agency. And so we may find that there are investments in certain types of activities, of technologies, of practices that are inadvertently replicated and therefore paid for multiple times, even though there are some opportunities for creating operational efficiencies. Or we've got citizen data in each agency, and that's replicated. So we've got the representations of the same individuals who live across the country, whether it's in a social services context, or whether it's in a internal revenue service context, or whether it's a military context, et cetera. We've got information about some of these individuals who are the same individuals, but the data is copied in silos across different agencies. And then we've got the need to share information across multiple agencies, but it's not being done. So you may see that there's social services data being stored in the Social Security Administration's data sets, and you've got health services, and you've got perhaps crossing the boundary between federal data systems and state or municipal systems, where again, whether it's within the judicial system, whether it's in justice, whether it's in commerce, et cetera. There's all sorts of opportunities for being able to better serve citizens. And we've got a bunch of examples, and I'm not going to read each one of these, but I'm confident that our friends at Pitney Bowes will make the slides or PDF slides available. But here's one example for intra-agency data repurposing. A good example is EPA, where they collect facility information from multiple applications, would make that available for other downstream applications. For example, cleanups in our communities, which tells us where areas of pollution are being or have been cleaned up in different areas. Let's go to the next slide, where we can talk about cross-agency data sharing. An example is the federal parent locator service system that is being run as part of Department of Health and Human Services. There's information there that is shared with the Department of Education to help improve debt collection from individuals who've defaulted on student loans. In the next slide, there's the motivation for paperwork reduction, where there's an increasing interest in taking paper forms and creating an electronic version of those. And as that's being done, there's more and more attention is being paid to what types of constraints are there for the information, since there's a very big difference between entering data into a system and writing something into a box on a form. And that because there's a lot more open opportunities for writing something on a form, we may have to introduce new constraints in terms of how the form is being filled out. So there's some scrutiny is being paid to during the 3-year cycle of updating the forms at OMB. In the next slide, we can talk about data standards for sharing information across agencies, interagency data standards. Good example is what is popularly being developed is the National Information Exchange Model, or NIEM, which is a standard to facilitate information sharing across different agencies. And here it's a standard and a canonical representation for data elements, for the tools and technologies for extracting data from your own systems, putting them into the standard representation, sending them out, and then having the recipients be able to reverse that process to take the data from its standardized representation and then be able to store it within their own organizational data sets. Next bullet item on the next slide is big data, and this is a buzz term that is being bandied about frequently these days, but really focuses on massive amounts of data. And particularly in the scientific community, we get these collections of sensor information from some scientific applications where there's millions, if not billions, if not millions of billions or billions of millions of data values that are being collected. Here's an example. A large Hadron Collider is going to sample and record the results of up to 600 million proton collisions per second. That's 15 petabytes, which is 15 million gigabytes of data annually. Well, that data's got to be captured, it's got to be validated, it's got to be stored, it's got to be managed, and it's got to be analyzed. And so we need some new ideas for how we can make that an efficient process. And I think we're going to kind of touch on some of those items. Naveen will touch on some of those as well. The next slide. Transparency. President Obama, early in his administration, talked about the need to create an unprecedented level of openness in government, and that translates into agencies being mandated and required to take their data and make it available. An example is through the data.gov website, which for a long time had been a good resting place for transparency, where agencies would post their data sets. Well, there are a lot of issues associated with this transparency, because the data is being extracted from a system that has its own models, but when it's being posted into a repository for subsequent use, there's no constraints on how that data is going to be used. We end up with a need to differentiate and understand the semantics and underlying structures of that data so we can make best use of that and ensure that it doesn't get used in a way that's inconsistent with its intent. The next item is about protection and privacy. Anytime that there's information that's being shared, there is a mandate, again, numerous laws in place to protect personally identifying data. Good examples are HIPAA. It's reinforced by the chain of healthcare related legislation, such as the HDRCA, and the Affordable Care Act. In the financial services, across the board, we've got Graham-Leach-Bliley. All these things have constraints associated with oversight and governing how data is being used to protect against the release of personally identifying data. And then the last bullet item we have is a coordination of interactions between public and private organizations. A good example is when there's benefits are being paid for health or the premium healthcare or health insurance premiums by government agencies, that there needs to be sharing of information between the health insurance company and the government agency to determine eligibility and to ensure that all parties are going to get their funding and their payment. So what's the big issue here? If we look at the next slide, if we've got an organically developed application wilderness where we've got data sets that are used as raw material to support the transactional or operational processes, that's the old world. In the new world, there's a greater need for sharing, for information management, for packaging it up, for sharing it, reusing the data in multiple ways, repurposing it for other agencies, analyzing that data in multiple ways, and then publishing, making that data available. What are the fundamental differences? Well, in the old world, data use is driven by the functional needs. But in the new world, information use is not driven by the immediate demands of a process, but rather the business and performance objectives of a collective set of potential consumers of that data, who can then provide some feedback as to what are the constraints and the needs and the requirements to ensure that data is being used in the most effectively. So we do have some challenges because they remain from the old world. If we look at on the next slide, I'm going to go through each one of these in greater detail. I'll quickly name them: complex infrastructures, proprietary environments, structural inconsistency, semantic inconsistency, entity identification, and then the need to be able to anticipate consumer data requirements. So let's look at each one of these in isolation. On the next slide, this is a simplified image of some of the architectures, quote unquote, that we've seen. I think calling that an architecture is probably being conciliatory at best. The way these organizations, many organizations evolve their systems is they buy a system, then they buy other systems because the systems that they have don't work, but they need to hook them up to the old systems, and then they need to have other systems that are hooked up to the new systems to take the data out of the old systems, pass through the new systems, and then dumped into an Excel spreadsheet. of which there are multiple copies, that everybody has a copy on their own desktop and nobody knows where they are. So there's a lack of coordination and oversight of the use of that data, especially when the data comes out of the Excel spreadsheet and then is placed in a bullet point in a Microsoft Word document or on a PowerPoint slide. There's no tracking of lineage. So being able to manage, when somebody actually puts that slide up after 3 months of data flow, and then somebody else in the meeting says, well, where'd you get that number from? That can spiral an effective argument into a significant stall in a discussion. So complex infrastructures rampant especially across agencies. The next one is proprietary environments. There's always the opportunity to try to reduce complexity in solving an acute operational or functional need by buying an application or buying a system. Well, many of these systems were designed to be closed, and the data is effectively locked up because the frameworks are hidden, or they're in a proprietary model, or the representations are modified somewhat. And in order to share information, you need to be able to synchronize that data with all the people who are requesting that information. That means planning, integration, and another key term that I think Naveen will touch on in a little bit, which is interoperability, and making that interoperability, especially from the data perspective, seamless and not a headache. In our next slide, it's somewhat a challenge that goes beyond the technology issues when we look at the hierarchy of success objectives that are defined at different levels. And this, again, is a byproduct of the way that agencies often do business, which is that there are there are agency objectives, and then there are program objectives, and there are project objectives. But when the project work is actually sliced off and contractors perhaps are engaged to put the system together, their success criteria are defined in terms of their project schedules and their project deliverables, not how the results of their deliverables fold into achieving the overall objectives at the agency level. So while we may have an overall desire to share information between agencies, that needs to be trickled down through all the numerous bureaucratic processes of acquisition to ensure that those high-level objectives are embedded within the low-level characteristics of the underlying project proposals, et cetera. And this is not a technical issue. This is one of coordination and again, data governance. And we haven't really even gotten to the data yet. I'm going to start talking about the data on the next slide, which is the question of structural inconsistency. And this is a good example. The example that I'm using here is a good example, and it's kind of abstracted to talk about postal codes. And the reason that I've seen the same kind of issue appear with numerous different types of data types that we always believe to be, everybody knows what they are. But here's a good example for a zip code. One data set has a 5-digit zip code for a 5-character string. Another one has a 9-character string to support a zip +4. So that was built a little more recently. But then you have another one that has 10 characters because the zip +4 string will include a hyphen between the first 5 digits and the last 4 digits. You might have another data set that needs to support foreign postal codes, like UK or Canadian postal codes, that might allow a 6-character string, and then others that use different lengths because they don't know what the postal code format's going to be. And so, I'll give another example. On the next slide, which is a little more detailed, has to do with what I call semantic inconsistency, where we use certain terms over and over again so much that nobody ever stops to define what it really means. And I like to use this example of what is a customer, and the reason I even use that example, even in the context of any type of set of organizations, is that we all act as customers, and we also often treat the people that we deal with as customers, no matter what they are. And I once stood in front of of a group of people in a certain company. I said, "What's your definition of customer?" And the salespeople said, "A customer is somebody pays for our products or services." And then somebody at another point in the room says, "A customer," they were from the customer support department. They said that's somebody who has a license for the use of our product. Now it turns out that the company was handing out evaluation copies of their product so that people could try it out before they actually paid for it. And when they did that, they were given full support. So from one perspective, a customer was one set of individuals, and from another perspective, it was a different set, and those sets of people didn't completely intersect. And what does it mean? It means that we've got potentially conflicting definitions for the same words that we use, and then consequently the underlying representations from different business functions and different processes and applications are going to differ as well. And then when you try to look at resolving the underlying definition, and you end up by looking at the representation in each organization's or each siloed application, you may find that there's a definition for the same term in 6, 7, 8 different systems. And then you might have software vendors or hardware vendors come in and they say, well, we've got our own opinions as well. So trying to resolve all of these things becomes a barrier to even getting to the point where you can share that information. Because, if you look at some of the things like NEEM, they even attempted to deal with some of these things and recognize that there are going to be times when the definition that is in the standard is not acceptable to the use internally. On the next slide, I'm going to talk about an emerging demand that I keep hearing about in the federal government, which is the need to recognize one individual across different or multiple data sets. So an example, look on this slide to the left. Those are different representations that my name has appeared. I usually pull them off letters that I get and who they're addressed to. I happen to, my name is David. I go by my middle name. My first name is actually Howard, and so when people ask for me for my first name, I don't know whether I should say David because that's what I want them to call me, or Howard because that's what my birth certificate and driver's license say. So there are multiple representations of that all refer to the same individual. That's my smiling face in the middle. Chris noted earlier that I'm an author of many books. If you go to Amazon.com and you type in David Lotion in the search, you'll get a whole list of books, of which some of them, like the first two on this slide on the right, were written by me. But there's another one written by somebody else who shares most of my relatively uncommon name, but that's a different person. I didn't write a book called the Geometrical Optics Workbook. That was written by another individual, and so here's the biggest challenge is that on the left side we've got multiple representations, but they refer to the same entity. On the right-hand side, I've got multiple entities, but they're all using the same representation. And it's one thing when you've got this problem within your own data set. It's another thing when you're trying to merge data or share data across different data sets within your own agency, or worse, trying to share data accumulated from your own agency with other agencies and their own representations, and having had 5, 10, 15, 100 different systems that were all engineered to represent the same first name, middle name, last name, social security number, but have them all in different representations, different lengths, different sizes, different data types, and then trying to resolve the combinations of those as well. So this is a big issue. What we do want to be able to do is leverage technology, but also leverage our processes together with the technology so that we can do things like managing shared reference data or understand the data about the data, et cetera. So let's go into each one of these examples as well. The first one is about managing shared reference data, and this, believe it or not, is one of the areas where there might be a great opportunity. If we go to the next slide, that we'll find that even the things that we think about as being well-defined often are not well-defined. And this is a scenario that was adapted from a real example where there were 3 different data sets that had been subject to sharing, and they were being linked by their identifying attributes. And they found that in the blue data set, when the record had a 0 in that one field, it had an M in the green data set and an F in the pink data set. On the other hand, when there was a 1 in the blue data set, there was the corresponding record in the green data set had an F, and the one in the pink record had an M. Now, if we think about this, you would immediately jump, if you looked at any one in particular, you'd probably immediately jump to the conclusion that this is a sex field. But what's interesting is that if you look at the data, if you analyze the data, you're going to see that the value domain, so a value domain is a set of values that are used for representing the concepts. They're different, but they refer to the same conceptual domain. So here, we've got a conceptual domain called sex or gender. It's got two conceptual values, male and female. I've got two value domains that are used to represent those concepts. I've got zeros and ones. I've got M's and F's. But I've got three mappings that map from the concepts to the values. One that maps male to 0 and 1 to female. One that maps M to male and F to female. And the other one, surprisingly, is F to male and male to female. Well, a little investigation revealed that in the pink data set, these are all data sets representing students in a university environment, and in the pink data set, the F actually stood for father, and the M stood for mother of the student, and that's why we have an F, but it really represents a male, and the M, which represents mother, actually was referring to a female. So if you look at the level of complexity in this one example, imagine what it means when you've got 16 different definitions of what a state is, and that you've got FIPS codes and FIPS character codes, and you've got FIPS digit codes, and you've got USPS character codes, and you've got different encodings for representations of what we believe to be the same concepts, but you've got overlapping conceptual values within those domains as well, where sometimes a state includes the District of Columbia and sometimes it doesn't, or sometimes it includes territories and sometimes it doesn't. In our next slide, we have a little more complex set of questions, which is, if I use a term, right, this is to address the whole semantic issue. If I use a term, what's the definition that I'm using it with, and how is that mapped to a representation in some actual data set? So I may have a term like a Social Security number, and I may have different uses of that term. One use might be for tax purposes, and one might be for beneficiary purposes. And then in that secondary definition, there may be two different data sets that I have data elements representing that same thing. One, if you look on the left, one is called SSN, and it's a length 11 character string, while in the other one it's called Social Sec, and it's a 9 length character string. Now they're really representing the same concept. They've got different underlying structural representations, but ultimately they roll up to the same definition, while we may have different data sets where it's being used for completely different purpose. We do a lot of consulting on data governance and data quality, and the next slide talks about putting together a data quality framework in place where you can inspect the quality of the data to ensure that it's meeting the needs of the collected data consumers, and that you've got processes and practices in place so that if you do identify an issue where the data is not sufficient quality for all of its uses, that somebody has responsibility and accountability to do some analysis, root cause analysis, identify what the source of the problem is, and to correct the process or to correct the data to ensure that the data doesn't cause a problem in somebody else's business process. And that leads into another higher level set of concepts on the next slide, which is the whole idea of data governance. And data governance is more than just assigning a set of roles and responsibilities to people called data stewards. It says, who are the business consumers of the data that we are producing? What are the types of things they're going to be using it for? What are their business goals? How are they being measured? How do issues or errors in the provision, accessibility, quality, completeness, accuracy of that data impact their ability to get their job done? What are the information requirements? And then how does that get filtered into systemic requirements for how that gets built into your system? Management for how you're managing the asset of, if we want to call data an asset, and then governance, what are the policies and processes that are in place to ensure that if there is an issue, that there's somebody who's going to address that issue, and that there's a sequence of fixed points for oversight to ensure that any reported issues are ultimately addressed and that people's needs are being satisfied. So when we're all done, we end up with a bunch of requirements for how we can put together what you might say a data management framework or a data management roadmap that addresses those business needs. And that says, instead of building our systems by saying what's the functional needs of the single user who I think is going to use it, reflect back on the fact that big data, data sharing, data exchange, data interactions, that is business analysis and data analytics, that's the future. So with that context, what are the business process dependencies on sharing data or repurposing data, both within your agency or external to your agency? Having identified those things, what are the business processes inside your agency or how you share information across agencies? What are the processes that need to change? And then fundamentally, who are the people within the organization and who have to make these changes, and are they ready, willing, and able to make those changes? And so we can kind of look at this from, if you look at this, the process arrow on the bottom, identifying what the business impacts are, what's the data that needs to be shared, what are the opportunity for introducing standards for process, standards for the data, standards for the functional uses and accesses of that data. How do we modify our business processes, and how do we put that together into an information management plan for effective government? And I'm going to hand it off to Naveen, who's going to talk about just one area. I mean, there's a fertile area for exploration. There's a lot of needs. And again, I'm going to thank the folks at PBBI for providing me with the opportunity to chat about this, and I'll hand it off to Naveen.
Thank you, David. Certainly a lot there in terms of the complexity of the environments and the opportunities to make that all right. What I thought was, the next 10, 15 minutes, I've walked folks through one of the key areas that we're seeing emerging as well as greatly being utilized across governmental agencies, both from the federal side but also state and local, which you talked about and you touched upon, which is this need for sharing data almost to the point where the data needs to be delivered just in time from a just-in-time consumption standpoint. But before we get into that, what I thought was take a little bit of a bigger picture view and walk you through some of the emerging trends from a practitioner point of view, so that our folks on the call also understand what are some of the major trends that are driving technology evolution in the data management space. So we get into the next slide. We see there's been a shift, as you rightfully pointed out, where data is increasingly being recognized as an asset. And this sort of trend, if you look back 20 years, started with just trying to get by in terms of cleansing the data for a particular operational or analytical use, which is very siloed for a particular department, was offline, to trends that we're seeing, as you rightfully pointed out, where the need to get information just in time, in real time, consistently across the enterprise as an event or a transaction is actually occurring, that need is that's where we are today, and that's where we're going tomorrow, and especially true in the public sector space. So there's important need for managing data in terms of creating the right governance policies and procedures around that. But then how do we take technology evolution that we've seen over the last 5 years, especially in the context of services-oriented architectures, to deliver those capabilities as a set of enterprise data services that can be delivered to any process or application within and across agencies? We look at the next slide. What we'll find also is, the value add of the data in terms of its utilization across these business applications and processes is also increasing. So there is an aspect of getting to the data, as you rightfully pointed out. There's silos across in the complex environment in terms of where data sits, in what format it sits. Being able to access that data certainly serves as the fundamental building block to consuming the data for better business intelligence. Once we have access to data, you build upon that to ensure you have actual trust in the data. And this is where we put in place the right governance programs, the policies, the right rules to ensure that we are addressing the encoding issues, the semantic issues that you talked about rightfully. And then turning data into an understanding of whether or not it's relevant. So its relevance is where data then turns into actual information, right? So it's put into a context, and the question is, given this context, is my data right? And then from there, you begin to draw the right level of insight in terms of moving from data to information to actual knowledge. And our knowledge where you are actually predicting perhaps certain behaviors, certain patterns, where you are able to take action perhaps even before an event or a transaction is occurring. So that's sort of the value chain of that data utilization that we certainly see organizations are trying to strive for in terms of why there is this certain urgency around managing the data as an asset. So what I thought I would do is focus in on the very fundamental building block, which is how do we get to the data where it currently sits? And I know organizations have traditionally looked at it from a physical consolidation standpoint, which is the diagram on the left-hand side, which is the typical process of ETL, extract, transform, and load, or change data capture, where we're actually moving physical assets and combining them into a centralized repository for our data warehousing and business intelligence operations. Of course, the challenge with that approach is, there is a time lag in terms of getting data from these physical systems into a centralized repository. Certainly, there's the complexity of building out the actual rules and ensuring the right kind of data is put into the actual centralized repository, or even to individual data marts or distributed systems. And then you have the challenge of looking at information where we're now expending resources both on the hardware and software side, but also people resources in terms of managing an extra set of systems. In essence, what you end up doing is creating yet another silo, and that's nothing against the practices around data warehousing, data marts, but to a certain extent, that's how many of these silos eventually got created, right? So there was the right kind of approaches, companies buying companies, agencies merging, new information coming in. But there's also this tendency to, let me carve out my piece of information, data that I want to work on, and eventually that view, which was meant for a read-only operation, became the operational data store for a set of departments or individuals, where now you're actually writing to it and creating more information within those stores. So what we find is agencies, again, continue to struggle with the fact that they can't share information and be able to pull that information physically. We're seeing a new trend, which is that centerpiece within that particular slide around data abstraction, virtualization, and federation. So this is where we get into concepts of not actually looking to physically move the data elements across different systems, but in fact virtualize the view and deliver that view as a set of enterprise data services, the trend I talked about earlier. So instead what you're saying is, when I need a certain set of information, I want to be able to access it on demand and serve it up, whether it's for purposes of reporting, whether it's for purposes for consuming within the process inside of a business application. And then, of course, last piece, there is application-to-application integration in terms of messaging between one or many applications, which typically we find vendors in the space of enterprise application integration tend to address. So what I'll do is I'll focus in on the centerpiece, which is this idea of data virtualization, and talk about certain specific use cases where this has a play for many of our listeners on the call. Go to the next slide, please. So these are the various patterns when it comes to looking at data virtualization. And I'm going to go into each one of them briefly and touch upon the use cases. Some of the use cases that are prevalent for data virtualization include the federation of data, which is taking out information that may be sitting in silos and presenting it as a view across many applications. An extension to an existing warehouse where you don't have to or want to or have the time constraints to build out yet another ETL process. Also looking at enterprise data sharing, so taking one piece of information and sharing that across applications in real time. Really looking to build out a real-time enterprise from a data sharing perspective. And then the last piece is where we talk about how the cloud is, as it's evolving, becomes yet another source of information for us to be able to pull and push information back and forth from, as well as the data that resides within our own repositories. So let's look at, briefly look at some of these use cases. So take data federation, for example. Typical scenario, we have multiple databases with multiple applications that need information from these silos, and the data that's sitting in it perhaps is not in a compatible format. And we find, a typical request from someone in the project program management is, I have an application that requires data from multiple incompatible sources, and that's where virtualizing the data comes in handy, because now what I can do is I can quickly create a data flow and actually cache that information and then present it to the application as a web service or a virtualized database that I can connect to. And this shows you an example of how that happens. The next there's many more use cases in terms of creating federated views. I'm sure many of you have heard of mashups. This is a great way to mash data across various systems, or even create virtual marts, so you're not actually creating these physical stores for one-off processes that tend to take form and shape of its own, and they live live forever, essentially. So creating a virtual environment where you get what you need, and then you can actually move on and not have to worry about maintaining that physical store. If you look at next example or use case is one of the warehouse extensions. So here we have a typical warehouse owner, and what he's trying to do is he's decided that he's created a warehouse, but he finds himself missing, or the business owners come to him and say, we have information that we need that's currently not in the warehouse. How long will it take you to get us that information coupled with the warehouse? So you can see the repository in the center is actually not connected to the warehouse, which is what we're trying to pull into this process. So this is, if you move on to the next click, you'll find himself, the warehouse does not contain all the data, and we want to build reports that does not exist in the warehouse today. And this is, again, where data virtualization can actually help out, where we're now pulling in data from the warehouse, but also from this external source that's available to us, and then pushing it out to the application or the reporting process on demand without actually having to worry about creating a physical ETL process where we're moving data from one system to the other. And then there's many more use cases prevalent around this, where we're not only extending the warehouses, we're also looking at this as an extension to existing master data management hubs. We're also talking about federating the data that sits in a warehouse, creating a hub and virtual spoke, complementing existing ETL processes, and, of course, assisting with data warehouse migration objectives. Another example is one around enterprise data sharing. So this is how do I share data that I have available across many applications. So this is an example of an IT director who has a need to share the same data across multiple applications. And again, data virtualization can be an important step in delivering that data or information to these various applications in a consistent manner. Much like federation, but in terms of federating across systems, different data sets, you're actually looking to move the same information across different applications. And it also has many different use cases, one being creating an abstraction layer for data, but also creating standards compliant data services. Another use case we find ourselves oftentimes asked about is really how do we move, or how do we shift from working offline and trying to get the information we need to really a real-time enterprise. And part of that, of course, is getting to the data when we need it and delivering it to the business process as the process is actually occurring. So, as an example, maybe it's a citizen services where the citizen is trying to understand whether they qualify for a particular service or not. And part of that operation is accessing information about the citizen and their previous records from various sources and pushing that into the business process. Another example could be, think of the passport services. So I enter the country and being able to understand that at the point that I'm being checked for my credentials, I'm looking to reach out to one or many systems and then being able to deliver that back to the actual business process for it to then continue down its decision stream. So this is, again, where data virtualization can really begin to help out. And then, the last use case we'll talk about is the cloud, getting into the cloud infrastructure. So, and I know this is becoming imperative for many CIOs across the organization, both on the commercial side, but also on the public sector side, because of the increasing amounts of data that's now readily available in the cloud, both private clouds and private and public clouds. And so, how do you begin to then integrate and synchronize data between these systems and applications that are actually running in the cloud? Because the cloud is not necessarily replacing everything that we're doing within our own firewalls, but in fact is adding yet another source or many sources of information and data that we need to capture, we need to synchronize, we need to share, and make sure they're consistent. So this is, again, where data virtualization can really come into play in terms of pulling information from data that's sitting in the cloud, pulling information from data that resides within your own systems, and presenting it to an application or a reporting engine that needs it at a particular point in time. An example could be an integration with Salesforce.com, but certainly many other sources of public and private data clouds are available. I'll leave you with with this start. Again, this is the large view in terms of many patterns that are available in terms of use cases that data virtualization begins to solve. Data virtualization in itself is not the end-all, as David talked about. There's many aspects of a good and effective data management program, and all those pieces need to be in place. Certainly we talked about extending the value of data across its life cycle and use, from access to trust to ensuring relevance and helping you draw the right kind of insight. But certainly where we see a lot of struggle within the government agencies and entities is that foundational element, which is getting to the data regardless of where it sits and delivered at the right time to the right process. So that's why I kind of focused in this 10 minutes on the virtualization area, which is a new area and is an increasingly being adopted as a data integration style. It's not necessarily a replacement for existing ETL deployments or capabilities, but it's actually complementary and augmenting what you may already have. I'll leave you with this one slide, which is looking at it holistically from a practitioner standpoint, getting to where we're not just focused on the data virtualization or the access piece. We're looking at it from a deployment across the board, where we're considering data access fundamentally. If we go to the next slide, we'll actually get a better visibility of that. Here is an example, in fact, of several examples where data virtualization can actually come in handy for the U.S. federal government, in terms of requirements around creating dashboard views for data elements that sit across various silos, being able to pull information from, for example, in that case, people database, a programs database, and a regulations database, being able to get a single view of criminal terrorist activities across various silos as well, and various pieces of information coming in batch or real time. Operational business intelligence, so actually acting upon the specific piece of information as the process is actually occurring. Master data management is another trend, as I highlighted early on, which is beginning to drive this notion of how do we best manage data as an asset, and master data management coupled with data governance is really where organizations are starting to take notice about how best to take that and really draw the right level of insight from across and share across agencies. We're also seeing that in terms of being an intelligence analyst workbench. So I can just sit across a system and directly hit the data source and try to get information on demand. I may not be using it as part of a real-time process, but at least I'm able to pull that information on demand without actually having to worry about a physical movement. In the last piece, in the last slide, really kind of want to leave you with, in the last few slides, what does it really mean in terms of benefits for you? One of the things you get is an actual complete view of the enterprise. What the benefit is, of course, is it's up to the minute, so there is no time lag in terms of information actually physically flowing from a typical batch process. There's greater agility because it's faster time to solution. You don't have to worry about resource constraints. You can quickly get data from within the source, cache it out, and deliver it to an application. And of course, there's lower total cost of ownership, again, because you're not investing in the acquisition of physical data stores and software. And I'll leave you with this next slide, which is the last piece of slide, and I guess we'll open it up to questions. In terms of an ideal state data architecture, looking at, and as David talked about, it's just not looking at just one level or one aspect of data management, but how do you begin to define the right data models so you have the right semantics, so you know what the definition of a customer is, for example, across systems, creating a policy where you're profiling the data so you understand where the issues are, creating the right cleansing rules so you are looking at data that you can trust, consolidating that data, enriching it, delivering it out to a master repository, and then being able to virtualize and federate that data to whatever application needs it on demand. So with that, Chris, I'll turn it back to you. I know we ate up on some of the Q&A time, question and answer time. Hopefully, we have some questions that we can address for the audience.
Yeah, will do. Thank you both to Naveen and David. I invite our attendees to toggle back to the original viewing screen by clicking on the full screen button again. If anyone has a question, please type it into the pod to the left of the main screen. We will hopefully get to all the questions, but if we run out of time, we'll definitely respond via email. Also, an archive link of this presentation will be sent to you all in the next couple of days. We do have a few questions from our attendees. The first question is, what are the barriers to implementing this type of technology?
I'll jump on top of that. I think, and Naveen, maybe I'll just kind of augment a little bit about what you said, which is, one of the things that I was kind of focusing on is the need for better and more effective sharing of information, and yet doing that within the constraints of all the legal issues such as protection and guarded access. And I do want to point out that on the one hand, the techniques that you and I were both talking about are intended to make that work better. The challenges that I've and issues that I've heard about are less about the technology, but rather whether the technology creates new risks that might not be manageable within the organization, or might I hate to broach this barrier, but to say that it might be politically inexpedient to address it, because to some extent it may impact the way that the organization actually is used to working in. It's sometimes it's very hard to change. Sometimes there's some potential external backlash that perhaps you're sharing too much information. Perhaps there's internal negotiations with the legal groups to ensure that there's the proper memoranda of understanding for information sharing. Maybe there's some intricacy in the actual wording of the law that prevents doing something that is really a smart thing to do. I'll give a good example. In one environment, there was the law actually specified what the representation for the data would be in a single database. Well, if you do that, that kind of, if you don't build the database, you're violating the law, even though it might be more accurate and more consistent and more timely access to data if you use a virtualization technique as opposed to creating a batch updated system. So some of the barriers are that we don't always take into account what the we've got legislators being data analysts and data modelers, and we've got data modelers trying to be legislators, and sometimes they don't focus on where their best strengths are at the right times when systems are being laid out and designed. So I'm trying to it's not necessarily a technical issue. Sometimes it's a deep process.
I actually agree, and I'm sure there's more questions, but just to add to that point, I think this is where having data governance policies and procedures in place begin to address some of those concerns, if I'm not mistaken, right?
Yeah, I would agree with that.
Yeah.
Great. We have time for one more question. The next question is, where is a good place to start in understanding how to share data better?
I'll jump on top of that one also. I think in the experiences that we've had, a lot of it has to do with ensuring that there's some level of understanding among all the participants in that exchange of what they're actually exchanging. And sometimes that requires sitting down and defining some ground rules and some standards. And that's, you might say that's a governance issue. And sometimes it's just some brute force analysis of what is the data that people want to see. And in some cases, we've actually, we've gotten some good feedback by getting an analytical tool like Data Profiler or Data Mapping tool or reporting tool, and using that to do effectively a scan of the data and do almost what you might call a data assessment or data quality assessment or a data inventory to know, what are the things that we're storing in our, are we storing telephone numbers in a country name field and email addresses in a comment field, and are we actually representing, is the evidence of the actual data representative of what we intended to model in the first place, and where the gaps are, and how does that affect our ability to exchange data? I mean, in one case, you see that there's an expectation that you're going to be able to get a certain set of data values because that's the way the data dictionary describes the model, but in fact, nobody ever put any data into some of those fields, so it's effectively worthless anyway. So having some boots on the ground data analysis and understanding what your assets are, I always think that's a good place to start. Maybe you.
Yeah, I absolutely agree. In fact, we find many organizations sort of overlook that very essential step. And in a lot of the projects, we find there's a need to migrate to new systems. We're putting out a new tax system, putting out a new revenue system, and there is the rush to migrate information from these legacy systems. And as you rightfully pointed out, there is the encoding issues across these systems that are often neglected, which end up costing the program group that's actually working on it more time and delaying the project, where it really boils down to a decision of, do we delay the project or do we get the data in its current condition as is into the system and then worry about it after the fact.
Or have somebody else worry about it.
Or have someone else worry about it after the fact. So certainly I think profiling is certainly the best place we would recommend that everyone start.
Well, thank you, Naveen and David. That wraps up our presentation, Data Management Fundamentals for Effective Government. IMIX Group would like to thank David Lotion of Knowledge Integrity and Naveen Sharma of Pitney Bowes for sharing their expertise today. In the meantime, if you have any questions, please don't hesitate to contact us, and thank you for your time and attention.